Hi there, I hope all of you doing well. I am Hồ Bá Thanh, research professor at Seoul National University. I'm very pleased to introduce for you this research topic about CO2 enhanced water recovery for carbon capture utilization storage, a new generation of CCUS. So my presentation on the distribution of this idea for four main parts. First, the problem statement. The next, I will talk about CO2 enhanced water recovery, highlight some recent study, and my proposed study for CO2 enhanced water recovery. Why we need CCUS and why CO2 enhanced oil recovery is suitable. In order to tackle the problem about hydrological limit in the world, the CCUS coupling with water enhanced oil recovery is a trend to supply the water for the area with hydrological limits, and in the same time we can store the CO2 and keep the limit will be more linear. Okay. Nowadays there are a lot of location or area they are facing with water scarcity. You can see in USA, Europe, India, especially in China. There are a lot of location they have the limit about water in the soil. Therefore, the idea to enhance water recovery is one of the big trends to combine CCS and reducing the hydrological limits in the world. Therefore, the CO2 enhanced recovery is global for CCUS. I can say the CO2 enhanced water recovery romantic solution coupled with CCUS. Why? Because we can utilize the water for drinking or agriculture, and it is the benefit to recovery of saline aquifer because we will maintain the reservoir pressure and control the water reservoir for better utilization when you inject the CO2. And my main role here for reservoir modeling, I will try to utilize the reservoir simulation, machine learning to achieve this research topic. And now I will highlight some recent study about CO2 enhanced water recovery. Iterated, the idea it's not really about CO2 enhanced oil recovery, but they try integrated CO2 storage and right injection. And in this research topic, they mentioned that if they invest in the right injection well, improve the CO2 storage capacity. Of course, because it will be maintain the reservoir pressure is very good. So the research question here, we only one numerical model can answer the numerical simulation result. We will need to optimal well location to improve right injection in CO2 storage. The next research paper will answer about this. A study of CO2 enhanced water recovery, efficient, and reservoir pressure control. In this research study, they try to put the more they try to put the well injection and saline reduction in different locations in the reservoir model, and they investigated that the the lower they investigated that the distance between the injection and reducer. If the injection and the reducer distance is higher, the system storage will be decreased. Therefore, we need to make the minimize the distance between the CO2 injection and saline reduction because there are some interference boundary between these two well locations. So should we find a way to define the distance between the CO2 injector and right injector This is the research question raised from this paper. So the next paper they call the optimal well alignment and right injection for reservoir management during sequestration. But it's not enough because they didn't include so much glycosylation to evade the sequestration process. So the idea is could we optimize well alignment under local uncertainty for CO2 enhanced water recovery? So my conclude for research question here. First, could we optimize the well alignment under local uncertainty? Could we decide a suitable well design for reducing costs? Could we use other injection strategies to improve CO2 trapping and water recovery? And next, could we develop the integrated framework to include all of the issues? So by reading this review paper, I can summarize challenge in situation water recovery. First, that is cost of injection well is considered a shortcoming of CO2 enhanced water recovery. The production of saline water must be K1 backup of CO2 curve. The distance between injection and injection well basin, type in well, 5 volt or 7 volt. The local uncertainty of specific conditions such as permeability, porosity, and hydrological setting. And the next, risk of CO2 leakage from injection well. Monitoring technique from the lab. From our lab may be working on the tracer technique to tracer CO2 leakage. And the optimal injection strategy for reducing well operation costs start to observe by modeling and simulation using for monitoring reservoir well. That's all about challenge of CO2 enhanced water recovery. And now my proposing study for CO2 enhanced water recovery. I will consider the deep learning network, multi-layer network, and hybrid ANN to create a C model or leverage model to define the optimal well alignment injection story right injection in one single framework. I call that the hybrid optimization framework or machine learning assisted optimization for CO2 enhanced water recovery. And my objective is consider my research or my BD research using water alternating situation enhanced trapping in subsurface. Okay, so the animation shown here very interesting. When you inject the water will prevent CO2 move upward, and some CO2 will be more solubility with the water. Okay, and for the total trapping, the water will keep the CO2 will make the solubility more between the water and CO2. In the same time, the water will push the CO2 go to the board scale will be more. Okay, so this injection strategy will be very potential for coupling with optimization framework. They define the initial plan. I will use the 5 box pattern of study from the level Senton formation, and we will optimize the 4 box movement in on of the area in the reservoir. And I expected that the optimal framework will assist it in for very fast decision for the last few scale like this. Here is show the schematic of water alternating gas. The reason we call alternating because it's like a cycle. You see the blue is the water cycle and the red is the CO2 cycle. And by this cycle, we expected that we can raise more right injection center from the reducer, and then so we can monitor the pressure build up for better management. There are several optimization parameters we can consider: CO2 injection rate, water injection rate, and injection cycle for water, CO2 cycle, number cycle on water ratio. Utilize the number simulation, we can get the last training database and apply for the ROSI base model, and we can make the optimal solution for CO2 storage amount and the right recovery factor. That is the main objective when we coupling the ROSI model by reservoir simulation and deep learning or machine learning framework. I will try to define three scenario. First, we don't train the well location, and then we optimize the well element for WA0 set, and final, we consider robot optimization for WA0 set. We can get the right Jackson well element under the constantly. Each scenario consider 250 simulation run for generation ROC model. So it is so the schematic, the well orientation design may reduce the cost of the drilling. Okay, we can make the more well. We can make the horizontal well if defend the cost of the project. So that's all about the introduction about CO2 enhanced water recovery, and I hope this presentation is useful for you. Okay, you can maintain the attractor and the rehearsal in a different way, but of course in the practical it's difficult to we do like that, because for the model you can easy, but I'm sure that for operation there's some struggle and barrier we cannot decide the perfect form like this. But I can think that well orientation design is the way to reduce the cost. And my future plan to consider the approach. Okay, I will completion the optimization scenario, investigate the order injection strategy, will decide strategy for reducing operation cost, and investigation more challenge for CO2 enhanced water recovery for future projects. Okay, and my opinion for CO2 enhanced water recovery, the raw water quality may be impacted by CO2 leakage from deep storage site to saline shallow aquifer. The real chemistry will be reactive in the storage site and solely does. So CO2 diffusion into the rest water and related trend to the bedrock mineralogy in water chemistry. The CO2 moved into a shallow aquifer can lead to significant mobilization of lead and arsenic, very dangerous, and therefore contaminating the raw water near the diffusion location and further downstream will be one of the leakage or the risk when we try to apply the CCUS projects. Thank you for your listening my presentation. Keep calm and enjoy your research.